So what we're going to start with today is just talk about common factors and get an idea of what a greatest common factor, a GCF, is. This is probably not something you've seen before. You might have done a little bit of it in elementary school. I don't think you did it last year in grade 9. It requires a decent understanding of your times tables. So if you struggle a little bit with your times tables, it will make it kind of challenging, but there are strategies that we'll go over that you can use to work on this. Okay, so what are factors? Factors of a number or a term, which we're going to get to eventually, are all the numbers that divide into it evenly. What do you think I mean about evenly? Yeah, like a whole number. So what are the factors of 24? We don't have to do them in order. Just give me one or two. 2, 4, yep, 12. Is that all of them? What else? 6. 24. 8. 1. Yep. No, not 18. We're missing one. No? No? 3, yes, exactly right. So I think that's all of them. What strategy would you use if you weren't sure? 24 divided by 2 gives you a whole number. 24 divided by 3 gives you a whole number. And 8 is also a factor. That whole number that it gives you is, they go together, right? 24 divided by 4 gives you a whole number. So 4 and 6 are both factors. 24 divided by 5 gives me a fraction. So that's not one of them. If I put these in order, I get 1, 2, 3, 4. This is why I picked 24. It's got lots of factors. 5 doesn't work. 6 works. 7 doesn't work. 8 works. 9, 10, and 11 don't work. Then 12. Then 24. This is just numeracy stuff. 4 times 6 is 24. 3 times 8 is 24. 2 times 12 is 24. 1 times 24 is 24. Notice that they match up in pairs, because that's what multiplying requires, 2 numbers. So that all makes sense. Those are the factors of 24. That's what factor means. Something that divides into it evenly, or in other words, a whole number that you can multiply by another whole number to get whatever number you're talking about. The greatest common factor, the GCF, which is what we're really focusing on, of 2 or more, but we're going to just go with 2 for now, is the product of all the biggest factors that are common to all of the terms, or the factor, the biggest factor that's a factor of both. Okay? So if I'm looking for the GCF of 12 and 15, what are the factors of 12? 6. What else? 2, 3, 4. And I think that's it. 1 and 2 and 3 and 4 and 6 and 12. We want to include the 1 and the 12 as well for this purpose. And then what about 15? So 1 always works. Hold on. Does 2 work? No. Good. So 3 is the next one. 2 doesn't work. Why? Because 15's not an even number. So dividing it by 2 is not going to give you a whole number. Again, that's numeracy. So 3. What about 4? And this is where your mental math, your times tables come in. What is 15 divided by 4? Does that work? Doesn't work. So 5 is the next one. 6 doesn't work. 7 doesn't work. 8 doesn't work. 9 doesn't work. 10 doesn't work. 11, 12, 13, 14 don't work. 15 is the next one. So what is the greatest common factor? What's common between both those lists? The biggest number that's common? 3. So the GCF of 12 and 15 is 3. So see how you kind of have to know what factor means. You got to be able to come up with all of the factors of 2 numbers at the same time, or sometimes even 3 numbers, and see what's the same between those lists. And sure, you can list them out, but that's not the best idea. Ideally, you want to just be able to do it in your head and just write out the answer. You'll see a little bit why tomorrow when we start applying this to something. 36 and 24, oh boy, these each have lots of factors. We already did 24. 1 always works. Does 2 go into 36? 36 is an even number, so divided by 2 if you want to check what it is. So 18 will also be a factor. That's where you can use your calculator. Yeah, but there's some before that. I think we're going to try to do them in order. 4. There's one before that. What does it have to be? 3. Okay, so 36 divided by 3 gives you 12. 36 divided by 4 gives you 9. 36 divided by 5? Nope. 6 works. 7, 8 don't work. 4 times 9 is 36. 3 times 12 is 36. 2 times 18. 1 times 36. So 6 times itself, so it's kind of in the middle. And then again, it's those 2, those 2, those 2, and those 2. And then looking at our list for 24 from above, 1, 2, 3, 4, 6, 8, 12, 24. What is the biggest number common between the 2? 8's not in the top list. Go ahead. Can it be more than what?
1.
Yeah. I mean, look at 1 is common, 2 is common, 3 is common, 4 is common, 6 is common. Are there any others? 12. That's it. 24 is not in that list. 18 is not in that list. It's got to be in both lists. So 12 was right. Now, when you're looking at the list, I think that's relatively easy. It's the coming up with the list and doing it in your head and making sure you don't miss any that's probably the more challenging part. Okay? Now, this is a bit strange, a bit different. What kinds of things divide evenly into a variable? Well, x to the 5 is x times x times x times x times x, 5 x's. So if I split that up in different ways, just watch for a second. That's x squared and x cubed. That's x times x to the 4th. Right? So all of those things divide evenly into it. And our list is actually x, x squared, x cubed, x to the 4th, and x to the 5th. All of those things divide evenly. In other words, any exponent from 1 up to whatever the exponent is. So if we wanted to find the GCF between a to the 4th and a to the 7th, What's the biggest thing common between both lists? A to the 4. So what's the rule here? Like if you're looking at two variables, is there a way that you could kind of always determine what the GCF is? Let me write that down first. GCF is A to the 4. Yeah, see. Yeah, whichever one has the smaller exponent, or if you even had 5 of them, out of all 5, whichever one has the smallest exponent. You got a to the 4, a to the 7, a to the 11, a to the 20, a to the 50. It's whichever one is the smallest. Because all the other ones will have that many a's in it, but a to the 4 only has 4. What about between these 3? So if you understood that rule, you already know the answer. Whoops, y squared. So these two have 7 in common, but this one doesn't. So what's the largest that's common between both? Y to the 3 is in each list. So that's our GCF. So the smallest exponent out of all of them will be the exponent of the GCF, of the variable part. But then when you're looking at numbers, you got to be doing your times tables and be thinking about things that divide evenly into a number. So now, the next challenge is, what if we combine them? So on the back, let's do this separately. Usually we won't write out all of these extra details. You're going to try to just do it in your head. You could write it out if you have space or on scrap paper. But if we're doing the numbers first, what are the factors of 6? 1 works for both. And then 2, 3, 6. And what about for 9? 1, 2 doesn't work. 3. And that's it, so 9. Right? So 3. And then for the x's, x to the 5th and x squared, x and x squared, x squared. Like if you are getting this, you can already see that it's not really useful to write that whole list out every time, especially for the x's, because it's always just the smallest exponent. So what's the GCF? It's the 3 and then x squared. Three is the biggest number that's common between 6 and 9. And x squared is the smallest exponent, so it's x squared. That's the greatest common factor between those two terms. And like I said, tomorrow what we're going to add on to this, we're going to use this to do something. But this is the first step. So we're taking a day on its own just to focus on this. Can we do this without writing everything out? What is common between 15 and 30? What's the greatest common factor between 15 and 30? 15, because it goes into 30. So 15 is in the list of 15. It's the last one. And does 15 divide 30? Yeah. What would 30 be? 1, 2, 3, 5, 6, 10, 15, then 30. So 15 is in the list of 30. So the GCF for this one is 15. What's the GCF of the A's? A squared? Yep. Because I got a to the 9 and a squared, so it's the smallest exponent, a squared. What's the GCF of the B's? Good, b cubed. Another strategy that you might use is when you look at them, not necessarily writing out the entire list, but if you notice there's a big number that goes into one of them, and you know that it does, maybe just check it in the other. Right? You might not do all the dividing on your calculator. Divided by 2, divided by 3, divided by 4, divided by 5, divided by 6, divided by 7. That's kind of going to take a long time. That's going to be slow. But if you think, wait a minute, does 15 go into 30? 30 divided by 15. Right, it's half of 30. So you might just kind of do that one check. Okay, don't shout this out. I want to give everybody a chance to think about this. What are numbers that go into 12, 8, and 16? Your brain, you, might very well start thinking of all the numbers that go into all of them. And eventually you'll get to the biggest. Okay, so here's a tip. 1 always works, but 1 isn't very useful. Sometimes it'll be 1, but like when we start doing stuff tomorrow. But 1 isn't very useful. So we're looking for something bigger than 1 if possible. Anybody, what do you think? What's a number that goes into all of them? 4? What's another number that goes into all of them? 2 also does. So that's what I mean. Like, you might think about all the numbers. Well, 2 goes into all of them because they're all even. 12 divided by 2 is 6. 8 divided by 2 is 4. 16 divided by 2 is 8. But then, is there a bigger number? 12 divided by 4 is 3. 8 divided by 4 is 2. 16 divided by 4 is 4. And there's nothing bigger. So 4. And then what about the x part? Does that one have a 2? So x to the 1, good. So I've got x to the 2, x to the 1, and x to the 3, so the 1 is the smallest. And the y part is a little bit tricky. This has a y, this has a y. Doesn't have a y. So there's no y in common with each of them. So I could imagine some people putting y because it's in those two. But it has to be in all of them. And there is no y. No y. So it's just 4x is what's common between those three. Okay, one more. This one has a bit of a trick to it, doesn't it? So what's common between 13 and 6? Yeah, like some people might say nothing, which would be a fine answer. If you said nothing, I would say that's right, nothing. Nothing bigger than 1. 1 always works, but nothing bigger than 1. So there isn't anything else that's common between them. So we can't pull anything out. So could you write a 1? Yeah, it wouldn't be wrong to do that, but you don't have to. What's common between the x's? X to the 4, because I've got a 4 and a 5, so I take the 4, it's the smallest. Y to the 4, Y to the 1, so common between the y's, Y to the 1. So if I don't write the 1, that's how we would normally write that term, x to the 4 times y, like that. If you wrote the 1s in there, it wouldn't necessarily be wrong. Okay? But in some cases, maybe you don't have a coefficient because they didn't have anything in common. Or in some cases, you don't have one of the variables because one of the terms was missing the variable. Okay, so all kinds of different things can happen. And that's finding a GCF. Any questions?